Hello everyone, I am Kausal Patel from Mechanical Engineering Department at Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. In this video, we are going to discuss about the subject introduction, dynamics of machinery. So this subject has been offered in 5th semester Mechanical Engineering. Okay, and the subject code is 3151911. Now, prerequisites for this subject is the knowledge about the subject kinematics and theory of machines. This KTM subjects already offered in third semester mechanical engineering. So we can apply our knowledge of kinematics and theory of machines to study the dynamics of machinery. Okay, now this course is designed to give fundamental knowledge of behavior of machines under dynamic conditions. So in this case, we are going to study various machineries, mechanisms which is subjected to dynamic forces and dynamic couples. Now, teaching scheme and examination scheme. In teaching scheme, there are 4 number of hours for lectures and 2 number of hours for practicals. And total credit for this particular subject is 5. Okay, here there is no tutorial. Now for examination scheme, there is 70 marks of external examination. So here end semester exam would be conducted and you have to secure minimum 23 out of 70 marks. Then in theory, there is 30 marks for progressive assessment. So we can say mid-semester examination. So in mid-semester examination, you have to score at least 12 out of 30 marks. Now in practical, there is end semester examination, which is external viva examination, that is of 30 marks, and you have to secure minimum 50 out of 30. While in case of progressive assessment internal, so here this is internal viva examination in which you have to score at least 10 marks. So here total number of marks would be 150. Now in module 1, it is about dynamic force analysis of mechanisms. So in which these are the topics to be covered. First introduction, then the application of D'Alembert's principle, then we have to study equivalent offset inertia force, then dynamic analysis of folding mechanism. For that we can use graphical methods, we can use vector diagrams. Okay, we have already studied velocity analysis, acceleration analysis in kinematics and theory of machine subject. Okay, so we can use graphical methods. Here after acceleration we have to find out inertia forces and inertia couple. Then in dynamic force analysis of slider crank mechanism, we have to find out velocity, acceleration of piston, then angular velocity and angular acceleration of connecting rod. Okay, so by finding out velocity and acceleration, angular velocity, angular acceleration, we can further find out inertia forces and inertia couples, and thereby we can go for engine force analysis. Okay, other topics are dynamically equivalent system, then inertia in the connecting rod, inertia force in reciprocating engines, etc. Okay, in module 2, that is about turning moment diagrams for various types of engine and design of flywheel. So in which we are going to study turning moment diagrams for various types of engine, that are single cylinder 2-stroke engine, single cylinder 4-stroke engine, multi-cylinder 4-stroke engine, then single acting steam engine, double acting steam engine, etc. Okay, then by drawing turning moment diagrams, we can find out fluctuation of energy and fluctuation of speeds, Okay, then we can design flywheels which is used in IC engine and design of flywheel for punch presses. Module 3, that is about the balancing of rotating mass and reciprocating mass. So balancing is the method by which we can completely or partially eliminate the vibration. So in balancing, first of all we need to study introduction, what is balancing, what are the unbalanced forces, unbalanced couples, then what is static balancing, what is dynamic balancing, what are the conditions for both, then transference of force from one plane to another plane, then balancing of several masses rotating in different planes. Okay, so in this case the system is having both unbalanced forces and couples, so we need to completely balance the system. Then force balancing of linkages, partial balancing of reciprocating masses. Okay, then balancing of locomotives and its effects of partial balancing in locomotives, that are nothing but variation in tractive effort, swaying couple, hammer blow. So this is about the partial balancing of unbalanced primary forces, while for secondary unbalanced force we need to understand what is secondary balancing, then balancing of inline engines, balancing of V engines, balancing of radial engines. Okay, then finally balancing machines on which balancing procedure is done. Okay, in module 4, that is about gyroscope. Gyroscope, that is nothing but an apparatus by which we can understand the gyroscopic effect during various motion. So in gyroscope we are going to understand what is angular velocity, what is angular acceleration, what is angular momentum vector. Okay, and then we are going to derive the magnitude and direction of gyroscopic torque or gyroscopic couple. Then effect of gyroscopic couple on an aeroplane and naval ship, that we are going to study. Then next topic, that is stability of an automobiles under the action of gyroscopic couple, then overturning couple. Okay, then stability of two-wheel vehicles. Okay, in module 5, that is about free vibrations and damped free vibrations. So in which we are going to study various types of vibrations, basic elements of vibratory systems, mathematical modeling, and their simplification by finding out equivalent spring stiffness and equivalent damping coefficients. Okay, then single degree of freedom system. For that, the spring mass system. Okay, and for spring mass system we are going to derive the equation of motions for undamped free vibration. Then next topic, that is about damped free vibration. For that we are going to find out equation of motion for viscous damping. So in viscous damping we need to study what is damping factor, what is under damped system, what is critically damped system, what is over damped system, and logarithmic decrement. Then next topic, that is free torsional vibration of 2 and 3 rotor system. Now this is about the system which are having 2 degree of freedom and 3 degree of freedom. So for that we can get various modes of vibration depending on the number of natural frequencies. Okay, then next topic, that is torsionally equivalent shaft, torsional vibration of gear system. So all these topics are covered in this module 5. Okay, in module 6, that is about force damped vibration. In force damped vibration we are going to analyze the spring mass and damper system, and for that we can get both complementary solution and particular solution using various methods. Okay, for particular solution we can use vector representation. Okay, then magnification factor, force transmissibility, then we can also study frequency response curves. Okay, then force vibration with rotating and reciprocating unbalance, in which also we are going to study frequency response curve. Okay, forced vibration due to excitation of support. Next, vibration frequency measurement. In module 7, we are going to study about critical speed of shaft. So for that, first of all, we are going to take a shaft carrying single rotor without damping. Then we are going to find out critical speed of shaft carrying single rotor with damping. Then secondary critical speed in horizontal shafts and critical speed of shaft having multiple rotors. So all these topics are covered in module 7. Now for practical session, these are the list of experiments to be performed. So first one, that is static and dynamic balancing of rotating masses. So in which we are going to balance 4 unbalanced masses so that the system should not vibrate. Okay, then understanding the gyroscopic effect on using motorized gyroscope. So on motorized gyroscope apparatus, we are going to understand gyroscopic effect during various motion. Then longitudinal free vibration of simple spring mass system. Okay, which is performed on universal vibration apparatus. Then study of torsional vibration in shaft having single rotor and having two rotor system. So this experiment is also performed on universal vibration apparatus. Okay, then study of free damped vibration and logarithmic decrements. Okay, study of forced damped vibration. Okay, then critical speed of shaft, which would be demonstrated on whirling of shaft apparatus. Okay, and finally study of dynamic forces and turning moments in mechanisms, which is study based experiment. Okay, these are the major equipments required in laboratory, that are universal vibration apparatus and motorized gyroscope. Besides this, static and dynamic balancing apparatus and whirling of shaft demonstrator are also required. Okay, now course outcome. After completing this course, students should be able to summarize dynamic forces and turning moment diagrams in mechanisms. Then minimize unbalance in mechanical systems by means of static and dynamic balancing. Then analyze gyroscopic effect in aeroplane, ship and automobiles. They should also able to demonstrate longitudinal vibration, transverse vibration and torsional vibrations in single degree of freedom system. And he should also able to determine critical speed of shaft. Okay, so these are the reference books you can refer. I would prefer Theory of Machine by S.S. Rattan and Dynamics of Machinery by Farazdak Haidari. You can also refer the other books mentioned here. Okay, for particular module number 5, 6 and 7, you can also refer Mechanical Vibrations by V.P. Singh and Mechanical Vibrations by G.K. Groover. So all these books you can refer for your reference.